And then for this last part of the section, we are going to be given some type of situation or problem, and we have to determine if it involves a permutation or combination, and then find the number of possibilities. So once we determine it, we're going to calculate it with either our permutation or combination formula. So if you look at 33, it says a team of dodgeball players needs to choose a captain and a co-captain. Now, it really boils down to thinking about, is kind of that second thing, am I just choosing two people to be there, or once I choose a captain, that has an effect on the other one, the co-captain, so order does matter. So I'm talking about a captain and then a co-captain. So who's the captain and then who's the co-captain? Order matters. So that makes it a permutation. So the first thing is to identify. There's my first answer. And then I'm choosing a captain and a co-captain, so I'm arranging two. So I'm really doing the number of permutations, 9, arrange 2. And if you think back to the formula, which you should have written down, that is 9 factorial over n minus r, so n minus r is 7, divided by 7 factorial, which really, 7 factorial cancels with everything 7 on down and leaves me with a 9 and an 8 on top, so it would be 72. So there's 72 arrangements of a captain followed by a co-captain. That's a permutation. If you look at 35, 4 out of 13 students will ride in a car. So I've got 13 students, and I'm going to choose 4 of them. Order of the students doesn't matter. That makes it a combination. I'm just selecting a group of 4. The order doesn't matter. And so I'm going to do the number of combinations, 13, choose 4. Now that really, if you think back to the combination formula, is 13 factorial. All over, I do my n minus r, so 13 minus 4 would be 9 factorial. And then I need another r factorial down there in combination, so it'd be 4 factorial. And if you think about simplifying this, I'm going to make this a little bit bigger here. We'll come down, so that is, this 9 factorial will cancel and leave me basically with 13 times 12 times 11 times 10 on the top. And then I have 4 factorial, which is 4 times 3 times 2 times 1 on the bottom. So really that 4 and 3 would cancel with my 12. And 2 goes into 10 5 times. So what am I left with? I'm left with, everything on the bottom's canceled. 13 times 11 and times 5. So if I do 13 times 11 times 5, there's 715 groups of 4 chosen from 13 students. So combinations.